Welcome to Get Your FRQ On. This is from the Calculus AB exam, 2009 version B. It is question 5. In the question stem, we are provided with the graph of the derivative of a function f, limited information about the function f, some additional information about f prime of x, and a new function g of x defined to be g of x equals e to the f of x. In part A of the question, we are asked to write the equation of the tangent line at g of 1. In order to find the equation for the tangent line at g of 1, we need to find the slope of the tangent line at g of 1. Given that g of x is defined as e to the f of x, finding the derivative of g is an application of the chain rule. G prime of x would be e to the f of x times f prime of x. So g of 1 is e to the f of 1. In the question stem, we're given that f of 1 is equal to 2, so g of 1 is just e squared. G prime of 1 is then e squared times f prime of 1, and we are given in the question stem and on the graph that f prime of 1 is negative 4. So g prime of 1 is negative 4 e squared. So now we have our x value at 1, our g of x value, which is e squared, and our g prime value at 1, which is negative 4 e to the second. All of this information can be combined to give us the equation for the tangent line. So the equation of the tangent line of g of x at x equals 1 is y minus e squared equals negative 4e squared times x minus 1. In part B of the question, we are asked to find all values of x between negative 1.2 and 3.2, where the function g of x has a maximum. From part A of the question, we know that g prime of x is e to the f of x times f prime of x. Since the range of y equals e to the x is y is always greater than 0, we can conclude about g prime of x that the e to the f of x factor is always positive for all x. So the only time g prime of x could be 0 would require that f prime of x is 0. So, looking at the graph, f prime of x is equal to 0, and it's also in the question stem, I believe, that f prime of x is 0 at x equals negative 1 and x equals 3. We also know that g of x will have a local maximum when g prime of x changes from positive to negative. This can only happen when f prime of x changes from positive to negative. Recall the e to the f of x factor in g prime is always positive. So the sign change can only happen as a result of f prime changing sign. And this only happens at x equals negative 1. In part C, we are asked to determine the sign of g double prime of negative 1. The formula for g double prime is given in the stem of this part of the question, so we use the formula to evaluate g prime at negative 1. G prime at negative 1 is e to the f of negative 1 times the group f prime of negative 1 squared plus f double prime of negative 1. However, we've already determined that e to the f of x is always going to be positive. So e to the f of negative 1, in terms of g double prime at negative 1, will always be a positive factor. We also know that f prime of negative 1 is 0. So on the outside, the e to the f of negative 1 factor is positive. F prime of negative 1 is 0, so the f prime of negative 1 squared is also 0. So the only thing remaining inside the group is f double prime at negative 1. And if we look at the graph of f prime, we can see that f prime is decreasing near and at x equals -1. We can conclude from this that f double prime of -1 is negative. So we have a positive factor on the outside, we have a negative factor on the inside, and a positive times a negative is negative. So from this we can conclude that g double prime of -1 is negative. It is less than 0. For part D of this question, we are asked to find the average rate of change of g prime of x on the interval from 1 to 3. To do this, we'll use the average rate of change formula using g prime of x and g prime of 3 and g prime of 1. So substituting that into the formula for average rate of change, we have g prime of 3 minus g prime of 1 all over 3 minus 1, which is just g prime of 3 minus g prime of 1 all over 2. We know that g prime of x is given by the formula e to the f of x times f prime of x. We also know from the graph of f prime of x that f prime of 1 is -4 and f prime of 3 is 0. So if we substitute this information into the calculation for the average rate of change, e to the f of 3 times f prime of 3 minus e to the f of 1 times f prime of 1 simplifies to 4e squared over 2, which is just 2e squared. So the average rate of change of g prime of x on the interval from 1 to 3 is 2e squared.